everyone. Today I am taking a topic on nomenclature of fused ring systems, organic chemistry. I have already made a video on monocyclic compounds, naming of monocyclic compounds. Do watch that video to get a better connectivity. A very large number of heterocycles contain two or more fused rings. Some of these have common names or trivial names, but not all. At such times, the name is constructed by combining the names of individual rings. I have displayed a list of names here. What are the rules to be followed to do the naming? Now, since the system is fused, means there will be two or more than two rings. That means it is made up of two or more than two components. When it is made up of two components, one of the component will form the base component. The other will form the second component. The second component will be written as a prefix. This prefix is derived by replacing the E with O. Of course, there will be some exceptions, like pyrrole will become pyrrolo, furan will become furo. The base component will form the suffix. Now, numbering and labeling or marking. Now, numbering will be done to the prefix or the second component. The second component, numbers will be used and alphabets will be used for the base component. That is, the bonds that will be formed. They will be marked by as A, B, C, so on. And the atoms, they will be numbered as 1, 2, 3. So the site of fusion will get two numbers. Now here you can see 1, 2, two numbers and one alphabet. This will be written in square brackets. The converging root. That is, the alphabets must go in and the numbers both must go in the same direction. That is, both should be converging. Let us start with some examples. It will give you a clear idea of how to write down the names. So here, these are the few examples. The first one, this is a benzene ring. Let me open it and write it down for you. This is a benzene ring. Plus this is another ring. Now let us see from the trivial names. In the trivial names you can see this and this resembles. So it is furan. And this is benzene. Now how do we name it? The site of fusion. One will form the base component, the other will form the second component. Here, since the heterocyclic compound is present in this ring, that means furan contains oxygen. Therefore, furan will get the base component. Furan will become the base component. So, the name of this component will be written here. This will form the second component. Second component, the name will be written as a prefix. E will be replaced. It will become benzo. It is an exception, exactly only E will not be replaced. It will not form benzeno. It will form, the E will be replaced from here and it will form benzo. Now you have got both the names, the brackets. In this square bracket you will write the numbers of this site and the alphabet. Now this is the base component. The base component will get the alphabet. That is, it will start from here, A, B, C, D, E. This is a converging order. Now here it is a benzene ring. This benzene ring, you can number it from here 1, 2, 3, 4. You can number it from here 1, 2, 3, 4. From any side you number, the number will remain the same. So, or you can take any number. The ring, since it is carbocyclic ring, we do not consider the numbering here. Therefore, only the alphabet will be taken into consideration. Therefore, this is benzo B. Again here, when we see this, both the rings are the same. Both the rings contain oxygen atom. Both of them are heteroatoms. If I open it, I get the same kind of rings. Let me check in the trivial names. Do I have this kind of name? Yes, it is furan. So one of them will form, since both have the same number of rings, 1, 2, 3, 4, 5. Both are 5-membered rings. Therefore, one will form the base component, the other will form the second component. Let us take this as second component and this as base component. Base component will form the suffix. The second component will form the prefix. So furan, the en will be replaced to furo. Now let us write down the brackets. One will form the alphabets and one will get the numbers. Let us start the numbering alphabets. A, B, C, D and E. Oxygen, from here you get the numbers 1, 2, 3, 4. But I have already said it should be in the converging order. So A, B is in the converging order. 1, 2, 3, we are coming in this opposite direction. Alphabets are going in this direction. Numbering is coming in this direction. So we have to consider B as it is. But the numbers, instead of taking 2, 3, we have to take it 3, 2 to keep the order same. It is furo 3, 2, B furan. Now let us see this example. In this common naming system, you can see 6-membered ring. It is called pyran, and 5-membered ring, it is called furan. So one of them has to form the base component, the other will form the second component. The ring which has more number of atoms will form the base component. So this will be our base component and this will be our second component. Second component is furan. The base component is pyran. Furan will become furo and pyran remains the suffix. Now let us write down the brackets. Base component will get the alphabets. We will start from here. A, B, this is the fusion site, C. Pyran will get the alphabets. So pyran, B. Furan will get the numbering. It will start from here. 1, 2, 3, 4. Now, the alphabets are coming from in this direction. The alphabets are in this direction, the numbers are in this direction. We cannot change the alphabet, so we write it as it is. But instead, when we have to write 2, 3, the site of fusion, instead of writing 2, 3, to get this same direction, we will write 3, 2. So this is furo 3,2B pyran. Now see these examples. Let us first find out their trivial names. This is a 5-membered ring. 5-membered ring. 5-membered ring with oxygen as the heterocycle. It is called as furan. This one is next is containing nitrogen. Nitrogen 6-membered ring. It is called as pyridine. Now let us see while naming fused systems, whenever nitrogen is present, we select that as the base component. Becomes our base component, and this becomes our second component. The second component forms the prefix. Base component forms the. Now let us do the numbering and labeling. The alphabet will be given to the base components. So it will start from nitrogen. The least alphabet should come to the fusion site. So A starting from nitrogen, B, C, D, E, and so on. Now let us do the numbering. It will start from here. 1, 2, 3, 4, 5, and so on. Now let us see the order. A, B, C, A, B, C. They are going in this direction. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. They are going in this direction. So both of them are going inwards. So this is the correct order. We can directly write down the name. The alphabet for pyridine will be C, and the fusion site will get the numbers 3, 4. So our name is furo 3,4C pyridine. Let us do this one. This is furan, again furan. This one is again pyridine. Again, pyridine will form the base component, so the name will remain as it is. Furan will form the second component. So it will be furo. The alphabet will be near this, just to remember. We will start the marking from here A, B, C. And numbering from here 1, 2, 3, 4. So 1, 2, 3 is going this side. A, B, C is coming this side. So we cannot change B. We have to write B as it is. We cannot change the alphabet. But we have to change the numbers. Instead of writing 2, 3, we will write 3, 2. So our name is furo 3,2B pyridine. Now let us see this example. This one is pyrrole. Here you can see it is pyrrole. Pyrrole and this is furan. Now this contains nitrogen, therefore this becomes our base component, and this is our second component. The second component forms the prefix. The first component forms the suffix. Base component alphabets are given. We will start from here because nitrogen is near to this fusion site A, B. This site gets the alphabet B, C, D, E, so on. So it is in this way. Now oxygen is here, so we will number it from here 1 to this ring. This atom gets number 2, this one gets 3, 4, 5. So the numbering is like this. Both are in the same direction, therefore we do not have to change anything. Pyrrole remains B, and the numbers which are coming from here 1, 2. So our fusion site will get the numbers 2, 3. Let us do some more examples. In the trivial names, you can check. One is called pyridazine. The other one is called pyrazine. This is pyrazine. Both the heterocycles contain 2 nitrogen atoms. Now when we see them carefully, this ring has nitrogens at positions 1 and 4, and this ring has nitrogens at position 1 and 2. The nitrogen which has position 1 and 2, since it is very close by, the positions are close by, this component is selected as base component. And 1,4 position, that is pyrazine, will be selected as second component. Base component forms the prefix, second component forms the suffix. So let us write down the name pyrazino-pyridazine. Brackets. Now base component will get the alphabets. The 2 nitrogens, this bond will get A, so definitely B, and the fusion site gets C. Numbering, you do the numbering like this, you do the numbering like this or like this. Both will get the 4th position. So we do the numbering in such a way that they both converge. Now, A, B, C, it goes like this. So we will take the numbering from here, that is 1, 2, 3, 4, 5. So again this side it will be like this. The numbers will be 2, 3 and alphabet is C. So our name is pyrazino-2,3-C pyridazine. Let's see this example. In this you can see nitrogen is present on this ring, so this will form the base component, and this will form the second component. The second component will form the prefix, therefore this name, which is furan, will become furo. The base component will form the suffix. Sulphur and nitrogen are present. There is no trivial name. Sulphur and nitrogen, heteroatom, there are no trivial names. Therefore, we have to generate the trivial name using this Hantzsch widman table. So nitrogen is called aza and this is thia. Thia comes first. So we will number it like this: 1, 2, 3. It is 1, 3, thia, aza. And it is a 5-membered ring, so it will be 1, 3, thiazole. The base component gets the alphabet. So the alphabet will start from A, B, C, D, and 1, 2, 3, 4. So the fusion side is going inside and the other side is also going inside. Therefore, our name is 2, 3, D. 1, 3 thiazole. And let us see this example. Both the rings there is nitrogen present. One of the ring is having oxygen, the other one is having sulfur. Now let us check the trivial name. Do we have any such kind of name? We do not have. So we will have to generate the name using Hantzsch-Widman. Using this Hantzsch-Widman table, we will generate the name first. Now this is oxygen, this is nitrogen, so this is oxaza, and this is sulfur, this is nitrogen, so this is thiaza. So what is the name here will be oxaza. It is a 5-membered ring, therefore it is oxazole. And here it is thiazole. Both of them, here it is 1, 2 and here it is 1, 2, 3. So thia comes first, so it is thia, and aza comes second, so it is 3. 1, 3 and 1, 2. Now which one is the base name? Oxygen and sulfur. In this table, in this priority table, oxygen comes first and sulfur comes second. So oxygen and nitrogen, we will consider the ring in which oxygen and nitrogen is there as the first ring. So we will consider it as base component. And this becomes the second component. So thiazole will form the prefix. It will be thiazolo. And this becomes the suffix. I'll write down the name here, there's no place. So 1, 3 thiazolo, this becomes the prefix, and 1, 2 oxazole. Let us take this example. Here this is a larger ring and this one is the smaller ring. So this will form the base component and this will form our second component. The name of the second component here is thiophene. The base component is a 7-membered ring. Let us generate the name according to this Hantzsch-Widman table. It is thiapine. The base component forms the suffix. The second component forms the prefix. So thiophene, it is an exception. Thiophene becomes thieno. Now let us do the numbering and marking. The base component gets the alphabet. Start from here A, B, C, D, or start from here A, B, C, D. We are going to get D here. Numbering from here 1, 2, 3, 4. Numbering goes from here to here and alphabetical order is from here to here. Both are converging. Therefore, the number is 3, 4 and the alphabet is D. So our name is thieno-3,4-D thiophene. Let us take this example. In this system, this nitrogen is a part of this system as well as this system. So the one which has different heteroatoms is selected as the base component. This becomes our base component and this becomes our second component. Second component here is imidazole. The base component is, there is no name for the base component, so we have to generate the name. It is ox and aza. It is 5-membered ring, therefore it is oxazole. It is at positions 1, 2, 3, so it is 1, 3 oxazole. Now the second component forms the prefix, so imidazole will change to imidazo. And this will remain the same, it forms the suffix 1,3-oxazole. Now let us do the numbering and labeling. This is the base component, so our labeling will start from here, A, B, C, D and E. Our numbering will start from 1, 2, 3, 4, 5. So 1, 2, 3. The numbering is in this direction and the labeling is in this direction. So we do not change the labeling. The numbering, it will be, instead of coming 1, 2, we will take 2, 1, 1. So it is imidazo 2, 1B 1,3-oxazole. Let us take this system. Nitrogen here again is a part of both the rings. In this ring 1 nitrogen and this ring contains 3 nitrogens. Let us see whether it is having a common name. Yes, pyridine is the common name. Since there are 3 nitrogen present, let us find out the name of this compound. No common name is there, so we generate the name using Hantzsch-Widman table. It is 3 nitrogen, therefore it is triaza. And it contains 5-membered ring, 1, 2, 3, 4, 5. The position of the nitrogen is 1, 2 and 4. Iupacheadquarters. Now, this ring is 5-membered and this ring is 6-membered. So pyridine will form the base component. This forms the second component. So let us write down the name. It is 1, 2, 4 triazolopyridine. Now the base component gets the alphabet. It will start from here. From the fusion site, this forms A, B, C, D, E. Here, let us number now. Numbering starts from 1, 2, 3, 4, 5. So our numbers are alphabets. The alphabetical order is A, B, C. The numbering has to be done in this way. Therefore, it is converging since it is 1, 2, 3, 4. So our name will be, this is A and 4, 5. They are in order and therefore we will take the number 4, 5. So this name is 1,2,4 triazolo-4,5-A pyridine. Let us see this example. Let us see in the trivial names. Do we get any name here? Yes, called as quinoline. Now, quinoline, and this one is, it is called as pyrazine. Now, the system which contains two rings, that is quinoline, will be selected as the base component. And this ring system, even though it contains two nitrogen, will be considered as the second component. So our name will be quinopyrazine. Now let us do the numbering. Quinoline, it will not become quinolo because of exceptions. There are exceptions in names. Instead of just removing the E, we remove this lean and we make it quino. So quinopyrazine, let us do the numbering. The base component will get the alphabets. We'll start from here. The base component will get the alphabets. We'll start from here: A, B, C, D and so on. This second component will get the numbering. Either we go from here 1, 2, 3, 4 or we go from here 1, 2, 3, 4. It will be the same. Same number comes on both the nitrogens. So let us take, since we have taken A, B, C in this direction, let us take from here 1, 2, 3, 4. 1, 2, 3, 4. So numbering is also in this direction. We get B here. For quino, we get 2, 3. In the same way, you can generate names of several other cyclic compounds. Thank you for watching. Do keep watching. I'll be uploading reaction mechanisms soon. Do keep watching. Like, share and subscribe.